Right. So we've already done exact equations and non-exact equations. Now um, another type of first order differential equations is the linear differential equations. Now let's say you have this type of equation. So you have these two equations, two differential equations in two forms. All right, so you have two forms of differential equations. So the first form of differential equation is that dy over dx plus a function p in terms of x times y is equal to q of x, or a function, another function in terms of x. Now this, if you see an equation that is in a form like this equation, now take note that there is an equation p of x and a y. So as you can see here, that the y is only in what? To the power of 1. So meaning this is linear in y. Well, the other, as you can see, it's dx over dy. So baliktad siya. That's dx over dy plus a function in terms of y times x, or x to the power of 1. So meaning it's linear in x. So when we say linear in x, meaning the highest degree or exponent of any of a variable of the x or the y variable is 1. All right, 1, or a constant. Now if you have these two equations, then we have to follow this formula. Now that is if it's linear in x. I mean linear in y. Alright? Take note, linear in y. So if it is linear in y, then we integrate in terms of x. But if it's linear in x, then we integrate in terms of y. Right. Now, you can only say if it's that it is linear when it follows either of the two equations. This one and this one. All right? Okay. So it could represent any other variable. It could be in terms of di over dt, or even any functions of time and rates and etc. All right. So for uniformity, so I'm using x and y, but it could also be I and t or any other variable. Okay, let's have an example. So let's say we have this equation. So we have x times dy over dx plus y is equal to x cubed. Now, as you can see, we need to have an equation similar to the either of the first two. Now, you can already see here that it is linear in y because the highest x or the lowest exponent of y is 1 and the highest exponent of x is 3. Right? And so, we need to, if it's linear in y, we need to follow the first equation. So the first equation was, again, dy over dx plus p of x times y is equal to q of x. So how do we derive the equation to that form? Now we need to remove the x in the first term. So let's copy that. Now we need to multiply the whole equation by 1 over x. Alright? So what happens? So the first term, it cancels out x, leaving dy over dx plus 1 over x y is equal to, so x cubed divided by x is basically x squared. Now it's already in the form of the first equation. So we have your px then is what? 1 over x. And your qx, or q in terms of x, is x squared. Now, to get the solution to this DE, we need to follow the formula. So the formula for first order linear DE in y is y to the integral of p of x dx is equal to integral of q of x integral of px dx. All right. So substituting, so y to the integral of what is px, that is 1 over x dx is equal to integral of what is qx, that is x squared, integral of p of x, so p of x is already 1 over x dx. Now what is the integral of 1 over x dx? That is basically what? That is ln x, right? So substituting, we have y to the ln x is equal to integral of x squared to the ln x dx. Okay, so ln and ln cancels out, and so we are left with y, or yx, is equal to the integral of x squared times x dx. So that is basically the integral of x cubed dx. So what is the integral of x cubed? That is x to the 4th over 4 plus c. Let's simplify the equation further. We can do y is equal to, so you multiply everything by 1 over x. You'll get x cubed over 4 plus c over x. Right, let's move this equation a little bit. Basically, that's y is equal to x cubed over 4 plus c over x. This is then your solution to the DE. Alright? Let's have another example. So let's have this equation, this DE. Now, this already follows the equation dy over dx plus p of x times y is equal to q of x. So basically, what is your px? P of x is basically what? It's 1, and q of x is e to the 2x. So what is the formula again for this equation? So just like the formula earlier, so that is y e integral of p of x dx is equal to the integral of q of x e integral of px dx. Right? So substituting, so we have y e integral of 1 dx equal to integral of what is q of x? E to the 2x e integral of 1 dx. So integral of 1 is what? That is x, right? So basically that's e to the x times integral of e to x e x dx. Right? So by rules of exponents, we can simplify that e to the 2x can simplify e to the 3x dx. Alright? So what is the integral of e to the 3x? So it's basically just bring down the coefficient to 1/3 and retain e3x plus c. Can we still simplify? Let's simplify a little bit further. So let's multiply everything by 1 over e to the x. So basically there's y is equal to e 3x over 3e to the x plus c e to the x. So simplify, we now have y e 2x e to the 2x over 3 plus c over e to the x. Or basically that's y e 2x over 3 plus c e to the negative x. Now this is your solution to the DE. Alright? Let's have one more example. So we have this equation. There. So how do we know if we follow the first equation or the second equation? So let's distribute the first term. So we have x dx plus 3y dx minus x dy is equal to 0. Alright, so let's try. As you can see, you can already see which is it linear to. So it's linear in basically y. Alright, so as you simplify this one, so the goal here is to form a dy over dx or dx over dy. So since the dy isa lang siya, then it's easier to do dy over dx. So let's move the third term to the other side. That's x dy. And then multiply the whole equation by 1 over dx. We'll have x plus 3y is equal to x dy over dx. Alright? What's next? Now let's multiply everything by 1 over x. We'll have 1 plus 3y over x is equal to dy over dx. Then, what happens next? We follow either of the two equations. So we can already see here that it is linear in y, since the y is at the numerator. Alright, so it is linear in y. So let's try manipulating the equation. So this becomes dy over dx. If we transpose this one, if we transpose this term, so that's basically negative or minus 3 over x y is equal to 1. We now have the equation dy over dx plus p of x in times y is equal to q of x. So your p of x is what? Your p of x is negative 3 over x. And your q of x is basically 1. Alright, so what is the formula again? So the formula is y integral of e to the integral of p over x, p of x dx is equal to the integral of q of x e integral of p of x dx. Alright, substituting. So let's substitute. Oops. y e to the integral of what is p of x? That's negative 3 over x dx is equal to the integral of what is q of x? So that's 1 e integral of negative 3x dx. Now what is the integral of negative 3x dx? Basically, so you can take out the negative 3. You have negative 3 integral of 1 over x dx. So what is the integral of 1 over x dx? That is ln x. So you have negative 3 ln x. Or you can bring up the negative 3. That's ln x to the negative 3. Alright? Okay, substituting it back to the equation, we have y e ln x negative 3 is equal to the integral of, so that's times 1, so that's e ln x to the negative 3 dx. So you can cancel e ln. What's left is y x to the negative 3 is equal to the integral of x to the negative 3 dx. Now what is the integral of x to the negative 3? So that's plus 1 and bring down. So we have x to the negative 3. So what is the integral of x to the negative 3? That's negative 3 plus 1 is negative 2 divided by negative 2 plus c. Alright, so let's simplify the equation. We can multiply the whole equation by x, or 1 over x to the negative 3. So we have y is equal to x to the negative 2 over negative 2x to the negative 3 plus c over x to the negative 3. Now, by loss of exponents, so negative 2 minus negative 3. So that is negative 2 plus 3. So negative 2 plus 3, it's 1. So, oops. We have, that is 1. So we have negative. So let's take out the 2 first. So that is basically x to the negative 2 minus negative 3 plus, so let's bring up the x. So that's basically negative 1/2 x. So that's negative 3 times negative 2 minus negative 3, that's negative 2 plus 3, so that is 1 plus cx cubed. Alright, so let's multiply everything by 2 just to remove the 2 in the denominator. So you have 2y is equal to negative x plus, so 2 times c is still c, right? So that's basically still c x cubed. Now, this is then the solution to your differential equations. So that's it for linear DE in the first order.